This video is about solving trigonometric inequalities. This is AP Precalculus topic 3.10. If you appreciate the content, please give it a like. If you have not yet memorized these 9 trig facts, please pause the video and memorize the chart right now. Number 9. What are all values of theta on the interval from 0 to 2 pi, for which 2 cosine cubed theta minus cosine theta is greater than 0. Let's define the left side of the inequality as f of theta. And let's start by finding where f of theta is equal to 0. So I'm going to write it like this. Let's define it by saying f of theta is equal to 2 cosine cubed theta minus cosine theta. But instead of writing greater than 0, let's go ahead and put equal to 0 right now. Now we're going to factor this by noticing that we do have a common factor of cosine theta. So let's pull cosine theta out to the front, and then imagine what will be left inside the parentheses. Dividing this first term by cosine theta cancels out one of the cosines theta, so we will be left with 2 cosine squared theta, and then minus 1. When you divide cosine theta by cosine theta, you get 1. And this will all equal 0. So we will find our critical values that will go on the sign chart by setting each one of these factors equal to 0. So of course, setting the first factor equal to 0, we simply get cosine theta is equal to 0. Now, setting the second factor equal to 0, we would add 1 and then divide by 2. So that would give us cosine squared theta is equal to 1/2. But then I'm going to squeeze in a little extra work here. If we take the square root of both sides, that will leave us with cosine theta is equal to plus or minus. Don't forget the plus or minus when you take the square root of both sides. Now the square root of 1/2. You take the square root of 1 and the square root of 2. The square root of 1 is still 1, but the square root of 2 is left as radical 2. So we need to solve each one of these equations to find the critical values that will cause f of theta to equal 0. Let's start by focusing on cosine theta is equal to 0. We know that cosine is the x value on the unit circle, and right here at the beginning, the x value is 1. We're over here to the right. As we rotate to the top, the x value is 0. On the left, the x value is -1. At the bottom, the x value is back to 0 again. The question was, where is cosine equal to 0? Well, that's right here at the top, which is at pi over 2 radians. So that's one solution. So we will have a critical value of theta equals pi over 2. But also down here at the bottom, which is 3 pi over 2. So that's another critical value for the sign chart. 3 pi over 2. So that's it for cosine theta equals 0. Now, how about cosine theta equals plus or minus 1 over radical 2? We can find the reference angle by ignoring the plus or minus and just asking the cosine of what is 1 over radical 2. Some of you have memorized this fact in the form radical 2 over 2, but I need you to be familiar with both of them and know that they are the same. So we have memorized that cosine of pi over 4 is 1 over radical 2. Therefore, pi over 4 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 4. Since cosine is allowed to be positive or negative, we will have solutions in all 4 quadrants. The angle in the first quadrant with a reference angle of pi over 4 is pi over 4 itself. So I'll add this to my list later. We can think of pi as 4 pi over 4. So the angle in the second quadrant is 3 pi over 4. And the angle in the third quadrant is 5 pi over 4. We can think of 2 pi as 8 pi over 4. So this angle in the fourth quadrant is 7 pi over 4. These are the 6 values of theta that make f of theta equal 0. Let's use them to make a sign chart. When we make the sign chart, there should be a row for each one of these factors, and we should list the 6 critical values where f of theta equals 0 across the top. So your sign chart should look like this. Next, I would like to focus on the factor of cosine theta and indicate with an orange mark which of these critical values make cosine theta specifically equal 0. And those were these 2 orange values that came from setting cosine theta equal to 0. So pi over 2 and 3 pi over 2 make this first factor equal to 0. So these are the only 2 places where cosine theta might change signs. Therefore, I only have 3 intervals to check. I'll come back to this. All of the other critical values came from the second factor of 2 cosine squared minus 1. These 4 values of theta will cause this factor to equal 0. So I'm going to mark all of those. So my pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. These are the only places where the second factor might change signs. So let's go back to cosine theta. We need to decide whether this factor is positive or negative in each of these 3 intervals. In the first interval, we can just use 0. Since that is not one of the places where cosine is equal to 0, I can plug in this endpoint. The cosine of 0 is positive 1. So I know that cosine will be positive in both of these intervals. How about on the interval between pi over 2 and 3 pi over 2? Let's look at my little circle. In fact, I'm going to copy this over. Between pi over 2 and 3 pi over 2, a good value to use would be pi. The cosine of pi is negative 1 because that's the x value. So that tells me that cosine will be negative on this interval. Now, how about between 3 pi over 2 and 2 pi? That's between here and here. Actually, I can just use 2 pi. That's not one of the values where cosine theta is equal to 0, so I can plug in 2 pi. Of course, the cosine, the x value, is 1, just like it was at 0. So, positive in both of these intervals. Now, let's think about the factor of 2 cosine squared theta minus 1. In this first interval, I can use 0. So if I plug in 0, I get 2 cosine squared 0 minus 1. The cosine at 0 is 1, and 1 squared is still 1. So this is really just 2 times 1 minus 1, which equals positive 1. So this factor is positive in this first interval. How about on the interval from pi over 4 to 3 pi over 4? Well, pi over 2 is on that interval, and, well, let's do this mentally. Cosine is 0 at pi over 2 because that's the x value. So if I plug in pi over 2, I'm going to get 0. 0 squared is still 0. 2 times 0 is 0. So this is gone, and I'm left with negative 1. So that tells me that this factor is negative on this interval. Okay, next we have the interval between 3 pi over 4 and 5 pi over 4. All right, that's between here and here. A good value to use, of course, would be pi. At pi, cosine is negative 1. So I'm plugging in pi, but that's going to give us negative 1 squared, which is actually positive 1, minus 1. So this is 2 minus 1, which is positive 1. This factor is positive in this interval. Next, we have the interval from 5 pi over 4 to 7 pi over 4. That's from here to here. On this interval, 3 pi over 2 is a good one to use. The cosine, the x value, is 0 right here. So if I plug in 3 pi over 2, I'm going to get 0, which is going to wipe out this whole term, leaving me a negative 1. So this factor will be negative in this interval. And the last interval should be the same as the first interval, because plugging in 0 will give us the same answer as plugging in 2 pi. So we got a positive before, we're going to get a positive right now. Next, we determine the overall sign of f of theta in each interval. A positive times a positive is a positive. A positive times a negative is a negative. A negative times a negative is a positive. A negative times a positive is a negative. A negative times a negative is a positive. A positive times a negative is a negative. And a positive times a positive is a positive. Because we are looking for the values of theta that will cause f of theta to be greater than 0, the solutions will be in these intervals where f of theta is positive. The critical values where f of theta is equal to 0 will not be included, so we will be careful to use open circles on these critical values as I mark my solution on this number line. But what about the endpoints? Well, the endpoints are to be included. Okay, these are not critical values, so these will be closed circles indeed. So, in between, we are looking for the positive intervals. So we will have the interval from 0 to pi, union the interval from pi over 2 to 3 pi over 4, union 5 pi over 4 to 3 pi over 2, union 7 pi over 4 to 2 pi. The 0 and the 2 pi will get brackets corresponding to the closed circles. All of the other endpoints will be parentheses. Here's your final answer in interval notation and using inequalities. Number 10. What are all values of theta on the interval from 0 to 2 pi for which 2 sine squared theta plus 9 sine theta minus 5 is greater than or equal to 0? Let's call the left side of the inequality f of theta. So f of theta is equal to this expression. We begin by finding where f of theta is equal to 0. This is going to be a factoring problem. So let's factor this trinomial. 2 sine squared theta will only factor as 2 sine theta times sine theta. Next, we look at the 5, and this can only factor as 1 times 5. It matters whether we put the 5 here and the 1 here, or if we put the 1 here and the 5 here. I'm going to do a very short trial and error that I would normally do in my head. I'm just writing it down for instructional purposes. The key is that inner plus outer must equal the middle. When I say that, inner is these two, the product of these two. So inner, I have 5 sine theta. Outer is the product of these two. So outer, I have 2 sine theta. Inner plus outer must equal middle, and the middle is 9 sine theta. We control the signs, but there's no way to get 9 out of 5 and 2. We can, the biggest number we could get would be a 7. So that's how I know this is the wrong order. So I'm going to switch these and put the 1 first and the 5 second. Let's check again. Inner, we have 1 sine theta. Outer, we have 10 sine theta when you multiply. Inner plus outer must equal a middle of 9 sine theta. We control the signs, so if we let the inner be negative and the outer be positive, that will give us the positive 9 sine theta that we need. That means we need a negative here and a positive here. Also, notice that negative 1 times positive 5 does give us the negative 5 constant. We find the solutions to this factored version of the equation by setting each factor equal to 0. Setting the first factor equal to 0 and solving, we would add 1 and divide by 2. So we would get sine theta is equal to 1/2. Setting this equal to 0, we would subtract 5 from both sides, so that will give us sine theta is equal to -5. We immediately know that this small equation has no solution. That's because we learned long ago that the sine function oscillates between +1 and -1. Okay, it starts here. The sine function we learned does like this forever. It goes up and down, but the maximum value of sine is 1 and the minimum value of sine is -1. So sine theta can never equal -5. It doesn't go that low. So no solution. So we can focus on where sine theta is equal to 1/2. You can find the reference angle by asking the sine of what angle is 1/2. We have memorized that the sine of pi over 6 is 1/2, so pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want sine to equal +1/2, we will limit ourselves to quadrants 1 and 2, where the y value, and thus the sine function, is positive. The angle in the first quadrant with a reference angle of pi over 6 is pi over 6 itself, and we can think of pi as 6 pi over 6. So this angle in the second quadrant is 5 pi over 6. So that's 2 critical values that will go on the sine chart. Theta is equal to pi over 6, and theta is equal to 5 pi over 6. When you make your sine chart, you need a row for each factor. So I have a row for the 2 sine theta minus 1 and another row for sine theta plus 5. Across the top, you have your domain limitations and your critical values. Remember that this first factor of 2 sine theta minus 1 gave us sine theta equals 1/2, which led to the 2 critical values of pi over 6 and 5 pi over 6. So let's highlight these 2 critical values for the first row to remind ourselves that these are the only 2 places where 2 sine theta minus 1 might change signs. The other factor of 2 sine theta plus 5 had no solution when we set it equal to 0. So that means that this factor gave us no critical values and there will be no sign changes. So sine theta plus 5 will either be negative the entire time or positive the entire time. We know that sine theta plus 5 is always positive because sine theta itself has a minimum value of -1. We talked before about the fact that sine goes up and down forever, but it has a max of +1 and a min of -1. And -1 plus 5 is still positive, so this will always be positive. What about 2 sine theta minus 1? Will it be positive or negative in this first interval? We can use 0 as a test value since that's not one of the critical values. If you plug in 0 right here, the sign of 0 is 0 because that's the y value on the unit circle, and at 0 the y value is 0. So we have 2 times 0 minus 1. So this is 0 minus 1, which is negative 1. On the next interval between pi over 6 and 5 pi over 6, pi over 2 falls right in the middle. So let's use pi over 2 as a test value. If we plug that in, we'd have 2 sine pi over 2 minus 1. Sine is the y value, and the y value would be 1 at pi over 2. So this would be 2 times 1 minus 1, which is 2 minus 1, which is positive 1. The value in the last interval, we can use the test value of 2 pi, which will work exactly the same as plugging in 0. We got a negative before, we are going to get a negative again. What about the overall sign of f of theta? A negative times a positive is a negative times a positive is a positive, and a negative times a positive is a negative. We were looking for where f of theta is greater than or equal to 0. So we are interested in the interval where f of theta is positive or equal to 0. Remember, f of theta will equal 0 at pi over 6 and 5 pi over 6 because the factor 2 sine theta minus 1 is equal to 0 at these two critical values. These will be included in the solution since we are looking for where f of theta is not only greater than but also equal to 0. So I'm going to show that these values are included by using closed circles, and when we write the interval notation in a moment, I will use brackets. So here's the final answer in interval notation and as an inequality. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.